Good afternoon, all.
Good afternoon, ma'am.
Good afternoon.
Screen is visible.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Oh, okay. So in last lecture, mm, we have started the revision of the chapters, right? So first chapter we have covered up to the Nyquist and Shannon capacity formula. We have covered in last lecture. Up to that part we have seen. So in today's lecture, we'll cover next parts or next chapters. So the next is the capacity of the channel. So as you know that capacity of the channel, it is nothing but the capacity of the transmission medium is how much data can the particular medium can hold. So that is nothing but the capacity of the channel. So for that, the capacity of the channel is mostly depend upon the bandwidth and the propagation delay. Okay. Now, what is mean by the bandwidth is maximum rate of data transfer across the given path. So, capacity of the channel means how much data it can transfer or it can hold, and the bandwidth is nothing but what will be the rate of transmission of the particular data. Means at what speed the data can be transmitted. So that is nothing but the bandwidth. So that next part is the propagation delay. So propagation delay, so the definition, please pay attention that delay is nothing but there due to some circumstances, suppose the data is transmitted and it takes some extra time to transfer that data, then it is called as a delay. Okay. So propagation delay is nothing but the final time in which channel will occupy all it all the bits, that will be its propagation delay. Okay. So propagation delay means what? Final time means by considering all the times. For example, if the signal is jam or it takes some extra time to reach again to the sender, whatever. So whatever total time required to reach the bit to its final destination. So by considering all that time, this is called as a propagation delay. Okay, so that is if the bandwidth is 1 bits per second, bps is bits per second, then every second it can take 1 bit. Okay, if the bandwidth given is for example 1 bit per second, then every second it, what is the meaning of this 1 bit per second? For every second 1 bit data can be transferred. So after every second it will move forward, so that next bit could occupy the space. Means after every second, for the next transmission of the next transmission of the data, it may require some time, for example 1 microsecond, 2 microseconds, whatever. So we have to consider all that timing, and that is nothing but the propagation delay. So in short, propagation delay is total time or the final time which is required for every bit to reach to its destination. So that is nothing but the propagation. The reason behind taking this term here is that we are going to look some example here of where we need this propagation delay. Okay, so in short, by considering the propagation delay, capacity of the channel is calculated as bandwidth into propagation delay in case of the half duplex, and in case of the full duplex 2 into bandwidth into propagation delay. So that will be the formula to calculate the capacity. Now let's see. So this term already we have seen in last lecture. Round trip propagation delay is nothing but time taken by sending the message from sender to the receiver and again to the sender. So that is nothing but the round trip propagation delay. So remember these two terms, propagation delay and round trip propagation delay. There is a difference. Propagation delay is only one term communication, means from sender to the receiver, whatever time it may require. So that is called as an propagation delay. But round trip propagation delay means what? Sender to receiver and again back to the sender. So for round trip propagation we are going to consider all this time, final time. Now let's see one example which is asked in the GATE question. So as I already told, we are going to cover some of the GATE questions which are asked related with the particular chapter. So from the for the first chapter related with this part, this was the question in GATE 2005. What is the question? Suppose the round trip propagation delay for a 10 Mbps Ethernet having 48-bit jamming signal is 46.4 milliseconds. So round trip propagation delay is given as a 46.4 milliseconds. We have to calculate the minimum frame size. What is the minimum frame size that will be calculated? Now what the question is, they have given the propagation delay, also they have mentioned that there will be a 48-bit jamming signal, means signal is jammed for some amount of the time. Okay, and that also we have to consider for all these particular execution of a or for calculating the frame size. So that is the 48 bit, and the rate is what? 10 mbps. Okay, so from all this information we have to calculate what will be the minimum frame size of the particular or the for transmission of the data. So let's see how it is calculated. So suppose from A to B data is sending. Okay, and for this particular situation we are going to consider this data. Now see the solution. So what is given? Round trip propagation delay is given, which is equals to 46.4 millisecond. But along with this, there is also a 48-bit jamming signal is also there. Okay, so that also we have to consider. So total round trip propagation delay will be calculated as 46.4 plus 48 by 10 or 4.8 millisecond, because it is what? Bits per second. So that we have to calculate, that's why I have divided it by 10. So after calculating this term we will get 51.2 milliseconds, microsecond. So this will be the total round trip delay by considering sender to receiver and again back to the sender. I hope you have understood this term, why I have added this. Because remember the definition of the round trip delay. Okay, so again it has to go back to the sender. So that time is given as a 48-bit jamming signal, means as the signal is jammed, maybe the data will be again sent back to the sender. So that's why I have to add this in a 46.4 millisecond. So that we have added over here. So after that I'll get 51.2. Okay, so from this term itself you will get the answer, that is nothing but the D. Okay, so the minimum frame size will be the 512. That will be the minimum frame size. Okay, so the minimum frame length is calculated by using or multiplying it by 10 raised to minus 6 into 10 into 10 raised to 6. So though maybe this means you might don't know this formula and all, from here itself you will get the idea of the answer. So the D is the correct answer. काय केलं आपण बघा, राऊंड ट्रिप डिले किती दिलेला आहे, 46.4 मिलीसेकंद इट इज गिवन राईट. त्याच्यानंतर काय सांगितलेलं आहे, 48 बीट जॅमिंग सिग्नल असणार आहे. मग आपण राऊंड ट्रिप डिले किंवा प्रोपगेशन डिले कसा कन्सिडर करतो, वी हॅव टू कन्सिडर द टोटल टाइम, जेवढा काही टाइम लागणार आहे तो सगळा कन्सिडर करायचा आहे. म्हणून काय केलं, फक्त 46.4 मध्ये 48 बिट्स त्याच्यामध्ये ऍड केले. So after all this conversion, I'll get 51.2 and that will be the my final answer. Okay, so this is the answer for calculating the round trip propagation delay. Okay, I hope you have understood this. Any doubt in this particular question? Okay, I hope it is understood. Now this was related with the next part we have to see from this chapter is the techniques which are used for encoding of the data encoding and decoding. That part is the next part from the first chapter. So what is mean by the encoding and decoding? So encoding is the process of converting the data or given sequence of characters, symbols, alphabets into a specified format for the secure transmission of the data. Okay, encoding means what? Converting the data or given sequence of the character. So data means what? 1010 or any characters. If it is given, then we have to convert that into a specified format. So which are the terms, which are the types of that particular format that we have seen or we are going to see. So that is nothing but the encoding. And why encoding is done? So it is for the secure transmission of the data. Okay, then decoding is not exactly reverse process of the encoding, which is used to extract the original information from the converted format. Suppose I have a signals or the data is represented in a signal. So receiver needs the original data, and to get that original data, decoding is used. So that is nothing but the data encoding and decoding. So now on which data we are going to apply this data encoding and decoding? So that is nothing but the 1 and 0. Okay, binary data, and we are going to represent that binary data according to its form. So there are certain terms related with the encoding. So polar encoding and bipolar encoding. So it is also called as the unipolar encoding. Polar encoding is also called as unipolar encoding, which is also called as on off gain or simply OOK. Means it is having only 1 and 0. Okay, so if one is present, that is nothing but the presence of pulse, means presence of a signal, means signal is present. So you can see here, this is 1, and 0 is nothing but the absence of a pulse or absence of a signal. So 1 represent presence of a signal and 0 represent absence of a signal. So that is nothing but the polar encoding. Now, in as I told you, we are going to encode the digital data to digital signal encoding. So you can see here we are having this data 1010 is digital data, and that we are going to represent in a digital signal. So we have seen the types of the signal, analog and digital. So this is the digital type of signal where the square roots represent the data. So that is the digital signal. So this data is represented by using digital signal. But how it is represented? So for this represented, it includes some of the encoding techniques. Okay, for representation of such data, it is having some of the encoding techniques, and these encoding techniques are these. Okay, NRZ, then NRZL, I, Manchester, D Manchester, etc. So these are the main encoding techniques. Along with this, we are having the sub techniques also. So we'll see one by one. Okay, I hope digital and digital data to digital encoding, why we are doing mainly encoding कशासाठी केलं जातं? Yes, anybody? Why encoding is required? Hmm?
हॅकर्स किंवा बाकीचे लोक एन्कोडिंग डिकोडिंग करून आपला डाटा चोरू नये म्हणून.
डिकोडिंग करून चोरू नये डेटा. ओके, अजून? Yes, why encoding is required?
Secure the data.
To secure the data. Okay, अजून? So decoding is done at where who does the decoding, whether the sender or receiver? Decoding.
Sender.
Decoding. I'm not talking encoding. Decoding means original data. Okay. So that is done at the receiver side, not the sender side. Okay. So encoding is done by the sender, we can say, and decoding is done at the receiver side to get the original data. So I'm having these signals, right? I'm having this signal, but what the signal exactly represents? What is this and this and this? So what this particular signal represents exactly, to know that I have to do the decoding. This presence of a signal means 1, so my data will be 1. Absence of a signal means 0, my data will be 0. So that is nothing but the decoding of the data, and which is generally done at the receiver side. Who will get this signal? So that will decode the signal. So encoding is mostly used to secure your data. So both the answers are correct. So to give the more security to the data, we are doing the encoding. Okay, now let's see one by one. Okay, so first technique is the NRZ, non-return to zero. So this is the first technique. So what is this technique is? Non-return to zero, it uses two different voltage levels to represent binary values. Two different voltage levels means what? Positive and negative. So generally positive voltage represents 1 and negative value represents 0. मीन्स 1 असेल तर काय असणार आहे? पॉझिटिव्ह पल्स असेल, आणि निगेटिव्ह 0 असेल तर निगेटिव्ह पल्स असेल. And 1 is nothing but the high to low, and 0 is nothing but the low to high. So this is for this high to low and low to high. This is for generally for your information, that how positive will represent and how negative will represent. So 1 will represent high to low, so this is my positive signal, and 0 is nothing but the low to high, so this is my negative, means this is 1 and this is 0. Okay, so this is the NRZ technique. So we have seen the examples, so I quickly show you one these examples. without wasting so much time. So 0 is what? It is nothing but the negative value. So low to high, and 1 means what? High to low. So let's see. 0 is what? Low to high. So you can see here. So this is my positive side and it is the negative side. So 0 represents low to high. So I have started from low and to the high. ठीक है. Then 1 represents high to low. So from high to low. Again 0. So low to high, high to low, low to high. Now two ones are there. ठीक है. So if such cases are there, is consecutive ones or 0 means same data is there, then what we have to do, the signal should be continued as the previous one. ठीक है. Now for the one, what I have to represent? High to low. So maybe my signal will start from here, but as the next is also 1, I have to make the signal as it is continuously. ठीक है. So this is the one thing which you have to keep in mind always. Also here also it is what? 0. So I have to complete this one signal first, and 0 represents low to high. So my signal will start from here, but again the next term is also 0. I have to continue with the same signal. Okay, and then I will complete this one. Suppose instead of 1, again suppose here 0 is there. In case if 0 is there, then what will be the case? My signal will be continuous like this. If it is 0 again, this, if the same data is there, I have to continue as the signal as the previous one. ठीक है. So this is nothing but the NRZ, which is also called as the NRZL, means non return to zero level. So that is the NRZL. So we have seen some of the examples, no need to do repetition. Then NRZI. Okay, again it is a type of the NRZ, that is non return to zero, means again we will be having the zeroth line where the signal should not end, means it will be at the positive or negative side. And I stands for invert. Okay, now what is this invert? So if one occurs at the incoming signal, then there occurs a transition at the beginning of the bit interval, and for 0 there is no transition at the beginning of the bit interval. Means one असेल तर present of a signal, and 0 is nothing but the absence of a signal. So that is the only difference between NRZL and I. So either 1 and 0 for the starting bit, either 1 or 0, it should always start from a negative side. Okay, so let's see. So as the first bit is 0, instead of 0, maybe suppose here 1 is there, still my signal will start from negative side, not from the positive side. So first is 0. 0 represents absence of a signal. There is no transition. No transition means signal काही असणार नाही, फक्त blank. So it is represented like this. Now the next bit is what? It is 1. 1 means what? There is a transition. So what I have to do is that I cannot move forward like this. Okay, I have to go to the opposite side to make the transition of the 1. So I will complete this signal first, go to the positive side, and then I'll mark the signal for the 1. ठीक है. Again the next bit is 0, so obviously there will not be any signal, so no transition. Again 1, so you can see here now I'm at the positive side. So what I'll do, I'll go to the opposite side, invert, and I'll mark the signal for the 1. Again 0, so it will not be any transition. So 1, as I'm at the negative side, I'll again go back to the positive, then 1. Okay, so again 1. Remember, if it is NRZL, जर NRZL असतं, so what would have been done? काय केलं असतं, as these are the two consecutive ones or same data, maybe if it is NRZL I have to continue this signal, but it is what, inward, so it is not the case over here. So what I'll do, I'll just go back or inward, and then I'll mark the presence of a signal. Again 0, no signal, then 0, no signal, 1, negative 2, positive, and the presence of a signal. ठीक है. So this is the NRZI. What is the difference in L and I? NRZL means what? NRZL मध्ये काय होतंय? What one represents? It is positive voltage, and 0 represents negative voltage. So, and in NRZI, 1 represents presence of a signal, 0 represents absence of a signal. Difference is what, if, or the things which you have to keep in your mind is what, if two or the data is same, then what we have to do, in NRZL, we have to continue with the same signal, but in NRZI, should not, the signal should not get continue. It should get vary. That is the only difference. Okay. So these are the two types of the techniques, that is NRZI and NRZL. The next encoding techniques, समजलंय हे NRZI and NRZL. Any doubt? Everyone, those who are absent, please pay attention. Any doubt?
No, ma'am.
No. Okay.
No, ma'am.
Okay, fine. So next technique is the bipolar AMI. Okay. So bipolar AMI is nothing but it stands for, AMI stands for alternate mark inversion. Okay, alternate mark inversion. So what is this what is this technique? 0 means no signal, no line signal, means no transition will be there, blank means as it is, as like a NRZI. And for the one, positive or negative, but alternatively. Okay, means if first one represent positive, then second one will represent negative, sorry, negative. So alternatively, this one represent positive or negative. Okay, how, let's see. So first is what, 0. Now see here, NRZ is not there, means not return to 0 is not there, means we can, or the signal can return to the zeroth line. So we have to start the signal from the this zeroth line. Okay, so first bit is what, 0. So 0 represents no signal. Now 1 is what, either positive or negative. Okay, so positive we have taken, so let's start. Let's see, I will take negative, so it can be anything, so negative. Then 0 means same. Okay, now next is what, it is 1 is what, now here I have represented as a positive, sorry, negative, so the next one will be the positive. Again 0, no signal. Now here it is positive, means this will be the negative. Okay, again 1, so it will be the positive. Then 0, no signal, then no signal, and again 1, here it is positive, so next will be the negative. Okay, so it is very simple, bipolar AMI. AMI stands for alternate margin and inversion. So if one alternatively positive, negative, positive, negative, likewise we have to make the signal for 1. Okay, any doubt?
No, ma'am.
Okay, so this is the second technique. Then next is a pseudo ternary encoding. Okay, so exactly reverse to the bipolar AMI, means whatever 0 represents in AMI, so that will be for 1, and whatever 1 represents that will be for 0. So 1 means absence of a line and 0 means positive and negative alternatively. Simple. So what is this? 0. So 0 represent positive or negative. So let's start. So I'll take it as a negative over here. 1 represent absence of a signal, so blank. Now here it is negative, so the next 0 will be the positive. Okay, again 1 absence of a signal, then 0 as it is positive earlier, so it will be the negative now. Now 1 again 0 here negative, so it will be a positive signal over here. Again 0, so it will be the negative. 1 is blank. Simple. So AMI, sorry, bipolar AMI and pseudo ternary. Very simple. Bipolar मध्ये one alternative दाखवायचे, positive negative, and 0 represents blank signal or no transition. And in pseudo ternary, 0 represent positive negative alternatively, and 1 represents no transition. Okay, so these are the two techniques. Now, next is the biphase encoding. It is one type of the encoding techniques, and again it is divided into these two subtypes. Okay, whatever these techniques we have seen, so these are the polar encoding. Okay, polar means only one, and in case of the biphase encoding, only techniques are different. Means these are the two subtypes of this biphase encoding. Okay, so what is this biphase encoding? The signal level is checked twice for every bit time, both initially and in the middle. It means that for these two techniques, we are going to show the transition at the middle of a signal level. Okay, so that is nothing but the biphase encoding. So hence the clock rate is double the data transfer rate, and thus the modulation rate is also doubled. The clock is taken from the signal itself. The bandwidth required for this encoding is greater. Reason is it is checking the signal twice. That's why bandwidth is also required. It is also greater than the other techniques. So let's see which are these two techniques: biphase and biphase Manchester and differential Manchester, which is also called as a Manchester and D Manchester. Okay. So biphase Manchester or only Manchester, what is represented in this type of the encoding, the transition is done at the middle of the bit interval. So it is already defined, that is nothing but the bar. Then the transition for the resultant pulse is from low to high in the middle of the bit interval for input bit 1. Means if 1 is there, then signal should represent low to high, but at the middle of the interval. Where? At the middle of the interval. And if it is 0, if the bit is 0, then it will represent high to low again at the middle of the interval. Okay, 1 represents low to high, 0 represents high to low. So here, so middle of the interval means what? This is my one interval, huh? This one, from this to this. This is my one interval. So my signal will start from here at the middle, and this signal will end over here. So this is one signal. And suppose this is the signal, means suppose if it is representing 1. So this will be 1. Now for the next, it will again start from this point. It will go to the middle and here. So it is my the next bit. That is nothing but the next signal. Okay. So let's see. One is what? One is what represents? It is low to high. Yeah, it is given here. 1 represents low to high and 0 represents high to low. So see here. So 1 represents low to high. So my signal will go up to this for 1. इथं माझा पहिला 1 end झाला. The next bit is 0. 0 represents high to low. So high to low. Again 1 low to high. Then 0 high to low. Now again 0 over here. Again remember. आता काय झालेलं आहे हा 0 आणि 0. So in such cases, if the two bits are same, what I will do, instead of going to the middle of this second 0, this signal will end at the start of this bit interval. That's why it is called as it requires the more bandwidth, because it is checking the signal twice. Okay, that is the reason. So you can see here my 0 is ending over here. Actually it should end over here, but as it is the double 0, means next term is also 0, so I have to end it over here also, means at the start of the second bit. And this 0 is starting from here and up to, it will end to this particular line. So ह्या झिरोचं रिप्रेझेंटेशन बघा कुठपर्यंत आलं इथून, like this. Okay, at the, sorry, not this, up to this line. So this will be my 0. Next is what? 1. 1 is what? Low to high. So again low to high. But again the next term is 1. It should end over here and it will move forward. Again 1. So it should end over here. Okay. Then 0 is high to low. Again 0, so high to low. And 1 is low to high. Okay, so that will be the Manchester encoding. 0 represents high to low, 1 represents low to high. If same bit are there, then instead of completing that particular bit at the middle, it should end at the start of the next bit. Only remember this thing. Okay, so this is Manchester encoding. So these are some examples that we have seen. The next is the differential encoding or differential Manchester encoding. So as like a Manchester encoding, it is also, so the transition is also at the middle of the bit interval, middle as काढायचे. Now what the 0 represents? No inversion. No inversion means whenever 0 occurs, go back to the other side and again come back to the main side. Means suppose me positive असेल तर the positive, negative and again positive. So this is called as a no inversion. And 1 means inversion. Okay. So transition will always start from a positive side. So let's see. So as this is what? Either 0 or 1. First bit kahi aso. My transition should always start from a positive side. So let's see. So this is 0. So transition is starting from positive side. But what the 0 represents? Whenever 0 occurs, go back to other side and again come back to the main side. So it is starting from positive. So it will go to the other side means negative and again come back to the positive. So here my 0 is over. From here, then this and this. So this is called as a inversion. Okay, then next is 1. 1 means what? 1 represents inversion. So inversion means this to here. Now the 0 is there. So here it will end. Then negative to the positive and again come back to the negative. So here it will end. Okay. Then next is again 0. So negative, then positive to negative. 1 is inversion. So negative to positive. Again 1 positive to negative. Again 0, Go back to the one and this. So likewise, your signal will vary. ठीक है समझ लिए the types of the encoding techniques. Yes, Manchester encoding, the Manchester encoding. समझ ले any doubt? How many techniques are there? See, huh? First NRZ, then NRZI, then bipolar AMI, pseudo ternary, then Manchester and the Manchester. Total 6 techniques are there that we have seen. Any doubt in any of the technique? In first test, you might have experienced something, whether it is able to draw or not. Any doubt? काही डाऊट आहे का?
No, ma'am.
Everyone got it clearly?
Yes.
Yes, others. Only 33 students are present. Others? Any doubt? Anybody is having any doubt?
No, ma'am.
Okay, so this was the part which we have seen in the first chapter. So only 2 points are remaining from the first chapter. So let me open that. This one. So circuit switching and packet switching. आठवते का काही circuit switching, packet switching? Anybody can tell what is circuit switching and what is packet switching? Can anybody tell what is the difference in these two techniques? Can anybody tell? No. So what is circuit switching and packet switching? So these are the two types of the networks we can see. Means how the nodes or how the end nodes are connected with each other, and if multiple nodes are connected to any one device, how the communication is happening. So that is nothing but the types of the network we can say, or the arrangement or the way of arranging the nodes. So in the circuit switching, so how the data is to be transmitted, see here. So there are some users A, B, C and D. Okay, A wants to send message to the C. For example, user A wants to send a message to the C and B wants to send a message to the D. So what is this circuit switching is that once anyone request for a circuit or request for a path for transmission of the data, that particular path is totally allocated to the particular user. Means what, user A wants to send the data to the C, so it will request for this path to switching node. Okay, so suppose the path is not busy, means it is free, then this path is allocated to the user A only. In between, suppose user B also wants to send a data at the same time. So what it will do, it will request for a path, but as it is busy, it is not allowed to be to send the data. So unless and until user A finish its conversion or finish its communication. ठीक आहे. सो दिस इज नथिंग बट द सर्किट स्विचिंग. एकदा का एक पाथ अलोकेट झाला की जोपर्यंत त्या युजरचं कन्व्हर्सेशन होत नाही किंवा कम्प्लीट होत नाही तोपर्यंत दुसऱ्या कोणत्याही युजरला तो पाथ अलोकेट करायचा नाही. दॅट इज नथिंग बट द सर्किट स्विचिंग. फॉर दिस आय हॅव टोल्ड वन एक्झाम्पल ऑल्सो. Okay, it is a practical example we can say, but for the circuit switching I told you that if I reserve any table in hotel, so unless and until I finish my timing for the particular table, that table is allocated to me only. Suppose I have given the timing as 6 or 7 p.m, so up to 7 or 8 p.m. that table will be allocated to me only, though I am late to occupy that table. So totally the particular resource or the path is allocated to the one user only. That is nothing but the circuit switching. So it is the example of the telephone network. So it is a very old network. So we all have experienced this, that suppose I want to call someone. So once I establish a connection with that particular end user, means other user is not able to contact me or end user. Means this line is totally busy with these two users only. So that is nothing but the circuit switching. And packet switching is exactly reverse. That is nothing but in packet switching, multiple requests can be carried out by using the same path. So instead of waiting for a path to get fully free, user B can also send the data at the same time. So that is nothing but the packet switching. So packet switching, this is happening just because every data, or there is no restriction to travel the data. Okay, in case of the packet switching, the data means there is no restriction how the data can be traveled, so that is not decided. But in case of the packet switching, sequence number is important, and the reason is that any data can collect, or any data can choose any path. So it may possible that there is some rearrangement required at the receiver side. That's why sequence numbers are given to every data packet. What is mean by the packet? It is a small chunk of the data. Your whole data is divided into small parts, and that each part is called as a packet. Okay. For example, my data is ABCD and it is divided into these four packets A, B, C, and D. And in case of the packet switching, once it enters into the circuit, or once it enters into the network, any data can travel by using any of the path. There is no restriction. So maybe possible C will reach before A, D will reach after A, whatever. It can be possible. So for arrangement or the proper arrangement of this data, sequence numbers are required. So that's why in the packet switching, sequence numbers are given for every packet. Okay, so this is the working of the packet switching. And one more thing in packet switching is that once any node gets the data, what this node do, it just store that data and then forward that data. Okay, means what, एखाद्या नोडकडे जे काही कोणतं पॅकेट येईल तो नोड काय करतो, ते पॅकेट आपल्याकडे स्टोअर करून घेतो आणि नंतर फॉरवर्ड करतो. वाय इट इज रिक्वायर? सो दॅट इफ एनी पॅकेट गेट लॉस्ट इन बिटवीन, मध्येच एखादा पॅकेट लॉस झाला, फॉर एक्झाम्पल हा सी लॉस झाला, सो इन्स्टेड ऑफ contacting to the sender, this node can easily resend this C because it is having that data or that packet. So that's why every node first store the particular packet, whatever packets reaches to that particular node, and then forward it. जे काय त्याच्याकडे आलेले आहेत ते सगळे पॅकेट तो काय करतो, स्वतःकडे स्टोअर करतो आणि नंतर फॉरवर्ड करतो. ठीक आहे. So this is the difference between the circuit switching and the packet switching. There are certain key points which we need to consider related with the circuit switching, is that it is generally executed at the physical layer or by the physical layer. Then there is a continuous flow. So you can see here continuous flow of the data is there, means it is not divided. Then No headers are required as the path is fixed. Sender and receiver will follow the particular path that is fixed. So headers are not required. Efficiency is less. Reason is that at a time the particular path is fully allocated to the two users only. Okay, other user cannot occupy this path, so efficiency is less and delays are also less because extra time is not required, only two parties are there, so delays are also less. Related with this same uh, packet switching, yeah, circuit switching and the packet switching. If we consider these point, packet switching is executed at the network layer, then there is no continuous flow because the data is divided into small packets. In case of the packet switching, we require the headers because path is not decided, so any packet can travel by using any path, so it should know where to reach. That's why headers are required. Packet switching is having the more efficiency because every time the path is busy with the multiple users, means multiple users can use the same path, and in case of the packet switching, delays are quite late as compared to the circuit switching. Okay, so these are the key points related with the packet switching. I think I have missed a slide over here. Okay, so that is the difference between the circuit switching and the packet switching. Any doubt in these 2 points? Yes, any doubt? Can anybody tell the difference between these two? What is the difference between these two, circuit switching and packet switching?
No, ma'am.
No doubt or no? Can anybody tell what is the difference between the circuits? Okay,
No
no
doubt,
doubt.
ma'am.
What is the difference between these two? Yes, Shivani Sate, Shivani Gaikwad, roll number 4. What is the difference between the circuit switching and packet switching? Hmm. Yes, Shivani, unmute your mic. Don't know. Huh? Yes. Others, roll number 17, Snehal Naik. See, if you don't respond me, I'll mark your absentee, huh? Today onwards. Because I'm not getting any type of response. Only some specific students are giving me response every time. If I call anybody and if you fail to respond me, then I'll mark absentee. Tell me. Yes, roll number 4, roll number 12. Okay, roll number 4 and 12 will be absent for today's lecture. Next, roll number Shweta Jadhav. Shweta, roll number 9. Roll number 9. Okay, roll number 8. Then 9, 12. Hmm. Yes, Yogi Raj Deshpande, roll number 35. Yogi Raj Deshpande.
Yes, ma'am.
Okay. So, what is the difference between the circuit switching and the packet switching? Hmm? What is the difference? Yes, roll number 32. Have you listened whatever I have explained now? Yogi Raj. हम्म. आता जे एक्सप्लेन केलं ते ऐकलं का? हा.
Yes, ma'am.
Okay, so what is the difference between the circuit switching and the packet switching? See, we are repeating the chapter just for your sake, not for me. Huh? Yes? बरोबर आहे की नाही? Sheikh, Arun Sheikh. Are you there, Arun Sheikh? Okay.
Yes, ma'am.
So, ऐकलं काय लेक्चरला कोणते पॉइंट घेतले ते? What is the difference in circuit switching and packet switching?
सर्किट स्विचिंग मध्ये मेसेज डाटा सेव्ह होतो
आणि पॅकेट मध्ये
आणि नंतर त्याच्यामध्ये सेव्ह होत नाही, ते डायरेक्ट फॉरवर्ड होते.
ओके. पॅकेट स्विचिंग मध्ये काय होतं मग? येस, पॅकेट स्विचिंग मध्ये काय होतं? ओके, चला एक तरी सांगितलं. नेक्स्ट अजून कोण सांगेल? अरबाज, हर्षद. येस, अरबाज मुजावर. Arbaz.
Yes, ma'am.
Okay. What is the difference between the circuit switching and packet switching? Whatever we have discussed now. Can you tell? How the circuit switching is working? Diagram itself shows you, na? You can explain the diagram only. What is circuit switching?
Actually, user A wants to ask a request for need to request top 10 ones and other user recommended with user C.
Bar, huh? Then how the data is sent user A to user C communicate करायचंय. So हा काय करणार, याचा पाथ हा फिक्स झाला युजर ए आणि सी मधला. करेक्ट. त्यानं रिक्वेस्ट केली. मग बी चं काय दाखवलं इथं? रिक्वेस्ट आणि बिझी. मीन्स व्हॉट?
And busy.
कशामुळे असं आलं? कारण हा पाथ कोणाला लोकेट केलेला आहे? ए ला. करेक्ट. सो ऍज इट इज बिझी विथ द ए, बी इज नॉट अलाउड टू इंटरप्ट इट. म्हणजे बी ला अलाउड नाहीये ट्रान्समिशन करायला. सो दॅट इज नथिंग बट द सर्किट स्विचिंग. ठीक आहे. हा. नेक्स्ट हर्षद, व्हॉट इज पॅकेट स्विचिंग? हर्षद, रोल नंबर 71. हर्षद. Yes, Harshad. Okay, roll number 71 is also absent. Next, roll number Sheetal. Sheetal, oh, एक second. Sheetal Vagas.
Yeah,
Okay. So, what is packet switching? What is
डेट
packet?
डेटा हा डिफरंट पॅकेट्स मध्ये सेंड केला जातो मॅडम डिफरंट
Okay,
पार्ट
okay. Different path नाही path एकच असेल.
हा
Fixed path. But data is divided into small packets. ठीक आहे. Now, B आणि A दोघं पण simultaneous use करू शकतात. Why? Yes, why? Same path is used by A as well as B. Huh? Because as like a circuit switching, there is no fixed path or dedicated path is there. B can also interrupt the same path which is allocated to A. That is the main difference between the circuit switching and the packet switching. Okay, so very simple terms are there, these two, circuit switching and the packet switching. Okay, so the next point is synchronous and asynchronous transmission. Synchronous and asynchronous transmission, these are the two ways of the transmission, how the data can be transmitted. So first we'll see what is asynchronous transmission. So in asynchronous transmission, the timing of the signal is unimportant, means it is not important. Data can, means where the timing is not required. Sender, say suppose sender has sent the data as 10:30, so it can reach up to suppose 11:30, then also it is okay. Then in such cases asynchronous transmission is used of where timing is not important. What are the examples of it? Can anybody remember? I have told you the examples of asynchronous transmission. Yes, what is the example of the asynchronous transmission where the timing is not required or it is not that much important? Hmm?
Telephone.
Telephone. How is it possible? Timing is not required. Huh? सेंडरनं सपोज मी फोन लावला एखाद्या पर्सनला आणि त्याने रिसीव्ह नाही केला तर नंतर तो माझा कॉल रिसीव्ह करू शकणार आहे का? नाही ना. इट इज कंटिन्युअस ना, इट इज सिंक्रोनस ट्रान्समिशन, नॉट असिंक्रोनस. असिंक्रोनस मीन्स व्हॉट, मी एखादा डेटा सेंड केलाय किंवा मी फोन काय असेल, फोन नाहीच येणार एक्झाम्पल, मी एखादा डेटा सेंड केलाय पण तो डेटा त्याच टायमिंगला रिसीव्ह होणं इम्पॉर्टंट नाही. इट कॅन रीच बट it is not that much important. So email is one of the example of the asynchronous transmission where timing is not that much required. Email, correct? तुम्ही आता मेल सपोज मला सेंड केलं, क्लास टेस्ट 1 सेंड केली तुम्ही, so I told that up to 5 p.m. you can send. Still some of you are sending me at 5:30, 5:50, whatever. This timing is not important for you. Though I have marked absentee those who have submitted me late. But as email is an example of the asynchronous transmission because we can send the email, but it is not required that the receiver should always present or it should always there at the receiving side. So such transmission is called as a asynchronous transmission. Okay, so in asynchronous transmission process, transmitted information is encoding with the start and stop bits, specifying beginning and end of the each character. I hope you have understood the meaning of the start and stop bit we have seen in third chapter, while seeing the types of the frames or the framing types, character count, bit stuffing, that in that cases we have seen. So start and stop bits are used to classify the frames or classify the data. So as long as some pattern is followed, the receiving device can retrieve the information without regard of which is it is sent. So receiver can decode the information and it can get the particular or original data. Patterns are based on grouping of the bit stream into the byte. Usually 8-bit data is sent along with the link as a unit. The sender sends each group of the data independently, relying it on link whenever ready without regard of a timer. Okay, so that is nothing but the asynchronous node. Yeah, you can see here emails, forums, or the letters. These are the examples of the asynchronous transmission. Okay, so you can see this is the example. So this is my data 1111101. This is the data, and 1 and 0 these are added as a stop bit and the start bit. Okay, so what is this stop bit? Means the first frame is end over here and the next bit or the frame is started. Why these are used? Because to get the separation of the data or separation of the frames. So that is nothing but the asynchronous transmission. And what is the synchronous transmission? So continuous means 0 and 1 bits are not included in case of the synchronous transmission means direct flow of data. As data comes, it is forwarded. So that is nothing but the synchronous transmission. And the examples are these one: chat rooms, video conference, then telephone, telephonic conversation. Telephonic conversation आता सांगितलं ना example करून तर. So this is the example of the synchronous transmission, not asynchronous. Also this video lecture, okay, or online games. So that is also a synchronous transmission. Hmm? So these are the two types of the transmission, synchronous and asynchronous. Clear? समजलं? The difference between synchronous and asynchronous. Asynchronous means what? Data is separated by using 0 and 1. Okay, where the timing is not that much important. And in case of the synchronous transmission, timing is required, or the whenever data is sent, it should reach in a proper time and continuous flow of the data is there. No 0 and 1 are included to separate the data. So these are the two types of the transmission. Any doubt? Any doubt? No. Okay. So here we have finished the first chapter. Yes, any doubt? Doubt आहे का काय? No doubt. Okay, fine. So what we have studied in the first chapter, concept and the terminology, where we have seen the basic concept, then point to point multi-point communication is what, then types of the signal we have seen, analog and the digital signal, then transmission medium, that is guided transmission media we have seen, twisted pair, coaxial and optical fiber. These three types of the cables we have seen. Then we have seen the transmission modes, simplex, half duplex and the full duplex, that we have seen. Then impairments, transmission impairments, three impairments: attenuation, distortion or the delay distortion, and the noise. These three impairments we have seen. Then we have seen the concepts of the channel capacity, Shannon, Nyquist. These are the two scientists who have given the formula to calculate the capacity of the channel in case of the presence of a noise and absence of a noise. Okay, so Nyquist is used for where? Presence of noise or absence of a noise? Nyquistचा फॉर्म्युला कशासाठी यूज केलेला आहे? By considering, don't know, huh? By considering presence of a noise, and Shannon capacity formula is designed in case of the absence of a. Then encoding and decoding techniques we have seen. Then NRZ, NRZ, I, all these three just now we have seen. Then we have seen packet switching, circuit switching, synchronous and asynchronous transmission. So all these points we have seen in the first chapter. Now tell me, anybody is having any doubt, let me know. Okay, should I repeat anything or we will go for a second chapter? No doubt. Huh? Okay, so we will move to the next chapter. Okay, so unit number 2 is a reference models where we are going to see basically main 3 points only there. Number ATM reference model, then OSI reference model and TCP/IP reference model. These are the three main points from the second chapter. Though second chapter is too small to cover it in university question paper, it is having higher means most of the questions are asked from the second chapter. Okay, so let's see what are the content that we are going to see in the second chapter. Uses of the computer network, then network hardware, network software, then types of the topologies, OSI, TCP/IP, and ATM reference model. So that much part. So out of these, mostly used means most of the questions are asked each on each and every point. Okay, so let's see what is this. So no need to cover this. Huh? So what is computer network that we have seen? So number of systems are connected with each other for sharing of the data, resources, or applications by using some of the medium. Then it is called as a network, and these are the types of the networks which we have seen. Then next is the what is the uses of a computer network, where it is used mostly. So you are experiencing lot of uses of the computer network in your day-to-day life. So I have listed some of that here. First is the resource sharing. Okay, for example, uh, one printer is there and that is shared in whole department, so that is also possible by using the computer network. Then high availability of the data means as the data is copied or it is replicated in number of devices, so if any one device get crash, then that data is available in other device also. For example, suppose I have one file which is available on my mail as well as on my drive, so the same data I can access from both. So that is nothing but I can have the data available all the time. Okay, so that is one of the advantage. Then save the money. Sharing the resources will save money. So obviously one printer, if it is shared between the 2 3 people, so separate resources are not required. Then provides the powerful communication medium, means anyone can talk with each other though they are far away from each other. So this is highly useful uh, means advantage of the computer network that we are experiencing nowadays. Then services which are provided by a network for a particular or individual person. For example, we can do the online shopping, then video conferencing, mail, chat box, then online games, quizzes. So all these are possible due to network only. And along with this there are many uses of the computer network. So if the question is asked regarding what are the uses of the computer network and it is asked, so you can write all these uses. So it is very easy. Then next term, yeah, this is the one example or of how the architecture is formed or how layers communicate with each other. So that is the general view of any layers means or any model we can say how they are communicating with or how the data is sent between the different layers that is shown over here. So this diagram is shown mostly the flow of the data and the terms which are used in the network. So the flow is how suppose this is host 1 is sender and host 2 is a receiver. So generally what is said is that layer 5 is communicating with the layer 5 means host 1 layer 5 is communicating with the host 2 layer 5, but actually when the data is sent the data is traveled from layer 5 to layer 4 to layer 3 to 1 and physical medium and in the reverse direction to the receiver. Okay, so that is the general flow of the data 5 4 3 2 1, then physical medium, then 1 2 3 4 and 5. ठीक है. Now what is mean by the protocol? Protocol is nothing but the agreement between these two layers how to communicate what should be my data, what should be the what will be the size of the particular data, whether it is in encrypted format, if it is in encrypted format which technique will be used. So all these rules are decided by using this protocol. Okay, so the protocol is an agreement between the layer 5 of sender and layer 5 of receiver for how to communicate with each other. That is nothing but the protocol. And what is meant by the interface? Interface is nothing but which services can be provided by upper layer to the lower layer or vice versa. ठीक आहे. इंटरफेस म्हणजे काय, लेअर 4 लेअर 5 ला कोणती सर्व्हिस प्रोव्हाइड करेल or in reverse direction, that is nothing but the interface. Okay, and in case of the transmission of the data, physical medium is the main medium through which data can be sent by sender to the receiver. Okay, so let's see, this is the example what is actually happening in every layer. प्रत्येक लेअर मध्ये काय होतं, कसा डेटा सेंड होतो, that is given over here. So for example, at the first layer suppose my data is m1, so header is added for this data. When it reaches to the next layer it also adds its own header. Again next it adds its own header. So this is for the sender side, and at the receiver side when it moves forward or upward it just removes the header. Every layer just removes the header. Reason behind is that the particular data is already reached to that header or that particular layer, so it is not required now. So it just keep the header for which it is going forward. फक्त तोच हेडर तो ठेवतो की जिथे जाणार आहे डेटा. Other remaining headers it just removes. So this is the example of how the data is travel between the different layers. Okay, then next, some of the design issues of the network software. It is okay that this software is designed by using such type of arrangement. Then what is meant by the protocol interface, all things are okay, but while designing this network or this layered network, there are some issues which are discussed over here. Now you tell me what is meant by the addressing, why addressing is required. What is mean by the addressing or any issue, याच्यातला कोणताही माहित असेल तर सांगू शकता.
No, ma'am.
नो मॅम. ओके, कोणताच इश्यू माहित नाही ह्याच्यातला. आय एम टॉकिंग अबाउट द इश्यूज, डिझाईन इश्यूज. ओम.
Okay, ma'am. Okay.
ओके,
I
हा.
think.
सो What are the issues, design issues? Can anybody tell? Yes, can anybody tell any of these design issue? What is mean by the addressing? What is error control? What is flow control? Huh? Already we have discussed all these in third chapter. How the addressing is done, how error control is done. Huh? Yes. Addressing means what? This example, na? We are adding the headers and the tailors to the data because the data can travel in a through network by using any of the path. So for that purpose, the data should know where to reach. डेटाला माहित पाहिजे ना आपल्याला कुठे जायचंय त्यासाठी त्याला प्रॉपर सेंडरचा ऍड्रेस रिसिव्हरचा ऍड्रेस टॅग करून द्यायचा सो दॅट इज नथिंग बट द ऍड्रेसिंग then error control some strategies for detecting correcting error that are used which are those for example crcsl or hamming code so likewise these are used to control the error between the transmission. Okay, then flow control means what? Sender should not be too fast, receiver should not be too slow, there must be some synchronization between the sender and the receiver. So that is nothing but the flow control. Means senderचं जर खूप fast असेल, so what will happen? If the receiver is too slow, receiver will not get all the data which is sent by the sender. So sender will only send the data, but receiver is not that much capable to receive the particular data. So this should not happen. So there must be the control on flow of the data. Okay, so that is nothing but the flow control. Loss of sequencing that already just now we have seen in case of the packet switching. Why it is required? So maybe possible packets are not reaching in a sequential manner. Second packet is reaching before first packet. So receiver should understood the sequence of a packet or sequence of a data. If this happens, then what will be the strategy which is followed by the receiver? That should be discussed. That is nothing but the loss of sequencing. Okay, then long message acceptance. So some messages or some protocols or some layers are such that they doesn't accept the too much long message. For example, there may be some limit that 32-bit data can be accepted only. So if my data is of 64-bit, then what should be done? If too much data or too long data is there, then and if it is not accepting, then how it can be divided, what should be the minimum size of that data. So all these strategies should be decided in prior. So that is nothing but the long message acceptance. Okay, and last one is the routing of the data. What is routing? Among the available multiple path, the minimum path or the best path should be chosen for particular data. That is nothing but the routing. If I am having multiple path to reach to the Pandharpur city, okay, 4 or 5 paths are there, but I have to choose the path through which I can reach early to the Pandharpur. So that is nothing but the routing. Similarly, even in a network, so there are lots of paths to reach to the destination, but which path, the path which will reach in a minimum time or minimum distance, only that path can be chosen. So that is nothing but the routing. So these are some issues which are taken into consideration while designing the network or while designing the particular this layered architecture. Okay, so these are the issues. Then next point is the network topology. What is this network topology? It is nothing but the schematic description of a network arrangement connecting various nodes, sender and the receiver through lines or of the connection. Means how your how your nodes are connected with each other and which strategy or which arrangement they are following to send the data. So that is nothing but the topology. Okay, so there are some types of the topologies. For example, bus star, then tree topology is there, hybrid topology is there, so mesh topology. So these types are there. So we quickly see these types. First one is the bus topology. So bus topology is a network type in which every computer network and network device is connected to a single cable. So you can see here only one cable is there, and for this one cable different nodes are connected. Okay, this data travel to in one direction, and that only a number of nodes or number of machines we can add to only one cable. Okay, so that is nothing but the burst topology. So these are the features: no transmission data, only in one direction, means only one direction for transmission of the data is used. So every device is connected to a single cable. So you can see now what are the advantage. We can add any number of devices over here, means as only one cable is required, I can increase this network by just adding the nodes to only one cable. So that is the advantage. So obviously only one cable is required, so cost effective. So it is very and it is easy to understand. So that is the advantage of the burst topology. But what are the disadvantages? So if any one cable fails, this common cable fails, whole network will go down. तर सपोज हीच केबल फेल झाली तर काय होणार आहे, डेटा ट्रान्समिशन विल बी डाउन, मीन्स डेटा ट्रान्समिटच होणार नाही, बिकॉज होल नेटवर्क इज टोटली डिपेंड अपॉन ओनली वन केबल. सो डेटा ट्रान्समिशन इज नॉट पॉसिबल इफ this cable is break or it is or it is fail. If the network traffic is heavy, it increases collision in the network. Yes, because only one line or one cable is used, so obviously there will be lot of load on only one cable, so the transmission of the data will not be feasible if we goes on increasing the nodes. So that is the disadvantage of the burst topology. The next comes is the ring topology, where the number of nodes are connected with exactly two neighbors. Okay, so you can see here now this node is connected to this and this is connected to this and this, and this connection forms a ring like structure. Okay, so that is nothing but the ring topology. There are two types of the ring topology: unidirectional and the bidirection. Where unidirection means this only one ring is available, bidirection means along with this one link, one more link is formed as like this along with the first link, and it forms again a ring like structure. So two rings will be formed to connect the different nodes to each other. So that is nothing but the bidirection. What is the use of this is that for multiple purposes it is designed. For example, suppose this ring is get crashed, so this can be used as an alternative. Okay, so that is the first use. Second is that in some of the network one ring is used for sending purpose only, and second ring is used for receiving of the data purpose only. So it these are the two main purposes of designing bidirectional rings or bidirection ring topology. In case of the ring topology, token is the main thing which is used or which is responsible for transmission of the data. The station or the node which wants to send the data, that must have a token. एखाद्या स्टेशनला किंवा नोडला डेटा जर सेंड करायचा असेल तर त्याला काय लागणार आहे, त्याला पहिल्यांदा टोकन असणं इम्पॉर्टंट असेल. इफ दॅट पर्टिक्युलर नोड इज नॉट हॅव्हिंग द टोकन अलॉंग विथ इट, that is not able to send the data. Then where is this token available? So this token is continuously moving within the network. हे काय करत असतं, कंटिन्युअस मूव्ह होत असतं. So the station or the node which wants to send the data, that grabs this token and sends the data. If any station doesn't want to send the data, it just forwards that token to the next station. Okay, हे टोकन म्हणजे काय असतं, it is a bit information which is important to send the data. ज्या स्टेशनला किंवा ज्या नोडला डेटा सेंड करायचा आहे त्याला काय लागणार आहे, टोकन लागणार आहे. मग हे कुठं असतं टोकन, सो हे कंटिन्युअसली ह्या रिंग मध्ये मूव्ह होत असतं. आणि ज्या स्टेशनला सेंड करायचं आहे तो काय करतो, ते टोकन घेतो आणि डेटा सेंड करतो. सपोज एखाद्या स्टेशनला नाही करायचं तर तो काय करतो, हे जस्ट फॉरवर्ड्स दॅट टोकन टू द नेक्स्ट node. Okay, so that is nothing but the ring topology. What are the advantages of the ring topology? So the possibility of the collision is minimum in this type of topology. Reason is that the data is divided. Also, if any node want to send the data, that must have a token. So जोपर्यंत टोकन मिळत नाही तोपर्यंत डेटा सेंड होत नाही. So obviously data will be minimum. It is also cheap to install and expand. Expand we can easily expand it because only what we require is particular station should be connected to neighbors. So that is the only requirement. So we can install, we can expand the network at any extent. What are the problems is that troubleshooting is difficult in this topology. Troubleshooting म्हणजे काय की कोणत्या नोडला प्रॉब्लेम आहे ते फाइंड आउट करणं पॉसिबल नाहीये, or it is difficult in this type of topology. So that is the major disadvantage. And second is addition of the stations in between or removal of the stations can disturb the whole topology. Means मध्येच आता इथे टोकन मूव्ह होते किंवा इन्फॉर्मेशन सेंड केली जाते आणि मध्येच एखादा मला नोड मी काढून टाकला, फॉर एक्झाम्पल हा स्टेशन काढून टाकला, व्हॉट विल हॅपन, सो दिस डेटा विल बी लॉस्ट. ह्याच्यामध्ये जर दोघांच्या मध्ये कम्युनिकेशनच होणार नाही काय, सो द डेटा मे गेट लॉस्ट. सिमिलरली इफ सपोज इन बिटवीन आय हॅव ऍडेड सम स्टेशन, एखादा स्टेशन ऍड केला किंवा नोड ऍड केला, so again it will disturb the communication between these topology. So these are the two disadvantages of the ring topology. ठीक है. The next is the star topology, where all the devices are connected to a single device or central hub. It is called as a central hub, and these are connected or these number of stations or the nodes are connected to the hub by using the cable. So that is nothing but the star topology. The advantage of this topology is that we need, or it is easy to set up. What we require is only cable to increase the network or to add the number of nodes in that. So that is the only or that is the only requirement. So fast performance with few nodes and low network traffic, then hub can be upgraded easily and easy to troubleshoot. Yeah, this is the important. We can easily find out which system or which node is not working properly. That can be easily understood. What is the problem? So major problem is what? If this central device get crash, then what will happen? Nothing will happen. काहीच होणार नाही नेटवर्क मध्ये, कोणच कोणाशी संपर्क साधू शकणार नाही. So that is the major disadvantage. Then cost of installation is high. Performance is based on the single concentrator or the hub. So these are the disadvantages of the star topology. Still, most of the time it is easy to install or it is easy to form this type of arrangement. So it is mostly used star topology. Then next is the mesh topology, where every node is connected to every other node in a network. ठीक आहे. त्याच्यामध्ये काय असतं, हा एक नोड आहे तो नेटवर्क मध्ये जेवढे बाकीचे नोड असतील त्या प्रत्येक नोडला कनेक्ट झालेला असतो. दॅट इज नथिंग बट द मेश टोपोलॉजी. ओके. So these are the features, means how the mesh is connected to the, how many links are required. So that formula is given. Now these two techniques are used for transmission of the data in a mesh technology: routing and flooding. Already we have discussed. Routing means finding the proper path. Flooding means, what is mean by the flooding? How the data is transmitted. So in case of the mesh topology, mostly flooding means what? So suppose this node is having the data is suppose A. हा डेटा आहे, हा ज्याला सेंड करायचा आहे. कोणाला सेंड करायचं? सपोज ह्या नोडला करायचं, टू दिस नोड. So instead of choosing any one link to send the data. What this will do, it will just broadcast this data to all the links whatever available. Okay, all other links means instead of sending that data to this particular destination, this sender will send the data to all other nodes which are available in the network. That is called as a flooding. Means at a time sending the data to all the nodes which are available in a network. So it is nothing but the flooding. Okay, so with the help of these two techniques, the data is sent in case of the mesh topology. Okay, so partial mesh and full mesh means what? Partial means it is not restricted to connect to all these nodes. प्रत्येक नोडला कनेक्ट झालंच पाहिजे असं नाही. So maybe possible it will connect to one or two nodes only. So that is okay. And fully mesh is this one. This each node should or it must connect to every other node available in a network. So that is the partial and fully mesh. So these are the advantages. Fully connected, then fault is diagnosed easily, data is reliable because it is transferred among the devices through dedicated channels and links, provides the security and privacy to the data. So these are the advantages. Problems are installation and configuration is difficult. Suppose the network, now it is okay that we can easily understood that only 5 nodes are there. Instead of 5, suppose 500 machines are there or 500 nodes are there. So this type of arrangement is totally impossible. Okay, so that is the disadvantage or the problem of the mesh topology. Then cost of the cables are high and it requires lots of cables, so it is costly, and cost of maintenance also high. So these are the problems of the mesh topology. The next is the tree topology, where it is the variation of the star topology, means one hub or one central device is there to which other nodes are connected, and it forms a tree-like structure means first node, then it is again divided into the secondary nodes and so on. So it maintains the hierarchy of the nodes either from top to bottom or bottom to top. So anything can be possible. So it is nothing but the tree topology, and these are the advantages that it allows more devices to be attached. Yes, we can increase now, we can add, means I can add number of devices like this also, and I can form the structure, anything. It allows the network to get isolate and also prioritize from the different computers. Isolate means this can be my one network, only this. Okay, or this can be my one network, or this can be my one network. So I can form a small networks, isolated networks in a tree topology. So that is the advantage. Problems are what? In the central, if the central hub gate fails, then entire system fails. Same as a star topology, and cost is high because of the cabling. Because you can see we require lots of cables over here. And the last one is the hybrid topology. So hybrid topology, it is the combination of two or more topologies. So in case of the hybrid topology, we can say that the topologies which are having the problem that can be overcome with the combination of the other topology, and it is called as an hybrid topology. So the बस टॉपोलॉजीचा जो प्रॉब्लेम आहे तो स्टार टॉपोलॉजीशी कंबाईन करून रिकवर करायचा. So that is nothing but the hybrid topology. So you can see here mesh topology, ring and the star. These are connected within a same network. So it is an hybrid topology. So these are the advantages. It is reliable as error detection and troubleshooting is easy, effective, then scalable in size and can be increased easily. So we can add number of nodes as well as number of topologies in a same network. It is flexible, and problems is complex in design and costly. So these are the problems. Okay, so these are the types of the topology. So tell me if anybody is having any problem. Whatever part we have, also 3 points we have seen in this from this chapter. Which are these 3 points? This we have seen uses of the computer network. This also we have seen. and the types of the topologies up to this 4 points. Yeah, tell me, is there any problem in these 4 points? Hmm? Any problem? Okay, no problem. Fine. So we will stop here.